Today we're going to be talking about how we can prove that two triangles are congruent to each other. And what we're actually focusing on today are two shortcuts, because up until this point, we've said that if you want to prove that two triangles are congruent, you have to prove that all the sides of one triangle are congruent to all the corresponding sides on the other triangle, and all the angles on one triangle have to be congruent to all the corresponding angles on the other triangle. Okay, so I'm going to teach you some shortcuts today, and they are abbreviated as SSS and SAS. Okay, so these are our two shortcuts for the day. So our first one is called side-side-side congruence, and so you'll notice that each of the sides, right, starts with an S, so that's where we get the SSS congruence. And it says that if you have two triangles and the three sides of the first triangle are congruent to the three sides of the second triangle, then you know, their corresponding sides, on the second triangle, then you will know that the two triangles are congruent. Okay, and this works whether they give you the numbers and you compare, this side is 10, that side on the corresponding side on the other triangle is 10. If you do that, or if you just have it marked like I have here, where they tell you with the little tick marks, this side is congruent to this side. Okay, so it works either way there. You do still have to find three things, and this only works if you have all three sides of both triangles, or if you have a way to find those out and make sure that they're congruent. Okay. Our next one uses a new term we haven't talked about yet, and that term is called an included angle. So just like everybody likes to be included when their friends go to do something, that means you like to be in the middle of things. You like for people to have invited you and for you to get to go and hang out with your friends. Okay, angles are the same way. They like to hang out with their friends, the sides of a triangle. Okay, and so I have a triangle here. We'll call this triangle ABC. Right. And if I wanted an angle that is included between side AC and between side CB, okay, I'm looking for the angle that is created by those two sides. So I would be talking about angle C here. Okay, that would be the included angle on this one. Okay. If I asked about the included angle between AB and between BC, that included angle, okay, or the angle that is created by those two sides, is angle B. Okay? And we could do the same thing with the other two sides. And we could say the included angle between AB and AC is angle A. Okay, so included is going to mean it's between those two sides. Okay, or you can think of it as created by those two sides. That's going to be really important as we talk about our next shortcut. So this is our second shortcut, and it is side, angle, side congruence. And so you'll notice the two sides, right, are on the ends, and the angle is here in the middle, right? And so that's where we get SAS. It has to go in that order. That's really important. With the A in the middle, and that will help you remember that when we're talking about this definition or this shortcut works if you have two sides and the included angle. Remember, we just said the included angle has to be between those two sides. Okay? So if two sides and the included angle of one triangle are congruent to the two sides and the included angle of another triangle, then you know that those triangles are congruent. Okay, so what would this look like? Okay, so for example, if I have on this triangle these markings, so I know, let me go ahead and give it a name. I know that side AC and side BC both have congruency markings, and angle C is the included angle between those two sides, right? And then over here on my second triangle, I have, now remember, they may be rotated differently, okay? So I'm going to give you an example both ways, but they may be rotated differently. So on this one I have QS and SR, have the congruency markings, and the included angle there is S. Okay, so if we look, I have AC is congruent to QS, and I have BC is congruent to RS, and I have the included angle C over here is congruent to the included angle S over here. Okay. So in this case, I would know that these two triangles are congruent, and I would be able to write myself a nice little congruent statement. I'd be able to say triangle ABC is congruent to triangle QRS. Okay. Let me give you an example of some things that wouldn't work. Okay, so we have our two triangles here, and if, for example, instead of marking that angle S was the congruent angle over here, if I had said angle R is the angle that's congruent to angle C, then you'll notice angle R on our second triangle is not an included angle, right? Angle S was our included angle because it was between side QS and SR, because those are the two sides that come together to make that angle. And I can only use those two sides because they're the two sides that are marked as congruent to AC and CB on the first triangle. So this would not work. Okay, here's a third example. And at first glance, these two don't look like they're going to be congruent, but we have to pay really close attention. So we look over here and we see, okay, AC is marked as being congruent to QR, and we see that CB down here is marked as being congruent to SR. And we see that both of these have an included angle. So on this one, it's angle C is my included angle. On this one, it's angle R is the congruent angle. And so these two triangles are congruent, okay? And that's going to be really important here because when you look at them initially, they're not turned to the same direction. So what we did was we actually took this triangle ABC here, and it's like this is a mirror. This yellow line I've drawn here, it's like it's a mirror. And so it's actually been reflected over, right? So we took this angle, and it's congruent to this angle. And we took this side, and it's congruent to this side. And this side, the bottom is congruent to the bottom on this one. So it's been reflected or flipped over that line. Okay, and so one of the things that they like to do is they like to rotate, between the first shape and the second shape, or they like to flip between the first shape and the second shape, or something like that, just so that you have to really be sure you're paying attention. So one of the most helpful tricks I can give you is if they have it drawn like this in the book, it can be really helpful to try to draw them or they're oriented the same way. And sometimes it's a little bit easier to see whether or not the corresponding parts line up. Okay. So again, this is our shortcut. You have to go a side and then an included angle and then another side. Okay, and that's going to tell you, if you have that, then you can tell that the two triangles are congruent. And again, these are shortcuts because you don't have to find all three sides and all three angles. So instead of finding 6 things, you only have to find 3. I really appreciate you watching, and I will see you tomorrow in class. Have a lovely afternoon.